Welcome everyone to another lecture on the lecture series of Programming in C++. Today we are going to discuss about constructor and static members. So we are going to learn about object initialization. That means how the instance variables can be initialized for in particular objects. And we are going to talk about constructor, how we use constructor and what are the different type of constructor available in C++, how we can implement them, how we can use them. And then we are going to talk about another topic, that is destructor. So they are used whenever a object is being destroyed from the memory. And then we are going to talk about static members. So we know the term variable declaration and variable initialization. These two are two different terms. So how we can declare a variable? We can declare a variable by data type with the variable name, and how we can initialize the variable. So first time setting the value of a variable is called the initialization. So what we can say, we can write a equal to 5. But for these two statements, we can combine these two statements as a variable declaration and initialization statement, like int a is equal to 5. So this is a statement where we have created the variable, or we have declared the variable, and also we have initialized it. So whenever a variable is declared, a memory location is created with that particular name or with that particular variable, and when it is initialized, the first value is being assigned in that particular section. But so far, for objects, what we have seen, so we used to suppose this particular class, so this particular class name is line. So what we used to do, we used to create an object of this line, say L1, or suppose a line itself. So we have created an object of this particular class line. So what is happening inside the memory? So we have this line and all the instance variables. So here we have one data, so that is private data, that is length. So length is being created. Now we don't know any mechanism with which we can actually initialize this particular object, or we can initialize the data members or instance variables of this particular object at the time of creation. So there is no way. So far we have learned. So what we used to do, or we used to use a particular function called setter function. So we use this setter function, so set length, and we send some values on this uh, particular function, and we set the value of this particular object. So what we used to do, line dot set length, suppose 5. So it will set the value of uh, this particular object, or the instance variable of this particular object, to 5.0. There is no other way to actually create or initialize the value or the object at the same time. Here comes the working of constructor. So what constructor does? So this is a special member function of a class. So constructor can be considered as a member function. That means whatever operations we have performed in our previous class on member functions, they are all applicable in constructors as well. Constructor can have parameters, constructor can do processing as well. So it is a special member function, and this member function is called whenever we create an object. So whenever we create an object, this member function is automatically called. We don't have to specify anything. Like if we write line, this member function, constructor member function, is automatically called. So when we don't write any constructor, when we don't provide any constructor, so a default constructor that actually doesn't do anything, but this default constructor is being called by the compiler itself. Like compiler provide us a particular constructor if we don't provide or write our own constructor. So compiler provides this type of default constructor, and that default constructor is being called whenever we create an object. So what are the properties of this constructor? So it has the same name as the class name. So constructor has same name as the class name. So like any member function, so member we can provide the name for member functions, but for constructor the member function must be same as the class name, exactly same. That means for this particular class line, we should have a constructor like, or the constructor name should be like line. So as it is looks like a function, so it should have this braces, uh, and doesn't have any return type at all, not even void. That means this particular line, or this particular constructor will not have return type. That means we cannot mention any return type in this scenario. That means we don't mention any return type. So it is a member function, but the exceptions are the name should be the class name itself, and no return type. That means we cannot even write the void. It doesn't return anything. So this particular function will be called automatically whenever we are creating an object. So what we can do, actually we can use this particular facilities, because this function is automatically being called whenever we create an object. So what we can do, we can use that particular feature to initialize our objects. So what we can do, uh, just check, or just check this example. Here this is our constructor, so this is called the default constructor. That means a constructor without any argument, and actually does nothing. Or you can just set some initial values for your private members as well. So what we have done here, so we have this particular class, we have set length function, we have get length function, so this will return the get. So this is the setter function, this is the getter function, and we have this private member double length. So this value, length value, will be manipulated, not manipulated, accessed by these two functions. So set function or set length function will set the value of this length for a particular object, and get length function will return the length of that particular object. And this line constructor, so this is how we can construct, use or write our own constructor. So whenever we write our default constructor, compiler will stop providing the default constructor. So compiler will not provide us the default constructor if we have written our default constructor. So instead of compilers constructor, this particular constructor will execute. That means this line constructor will execute, and it, in this particular statement or in this particular block, whatever statements we are going to write will be executing. So I have written here that cout object created endl. So whenever we write this statement line, a message will be displayed on the screen. It says object created. So let's check it as an example in the code. So this is the example. So we have defined all these three functions. So this is the same class that you have seen in the slide. So this is the same class, line class. We have that private member double length, and we have the public section. We have the set length function that will set the value of this particular length. We have get length function that will return the value of this particular length, and we have this line constructor. So we, in this particular case, we have defined this line constructor outside the class. So the idea is simple, just we don't have any return type. As we don't have any return type, we don't have to mention the return type. So what we can mention, we can mention the uh, class type, then scope resolution operator, then the constructor name, that is itself the name of the class. So line, uh, scope resolution operator, line, and we don't have anything, that's why we have sent void. You can just if this particular constructor doesn't do anything, you can just don't need to send anything. So it is void, or you can just keep it empty as well. Both of them is fine. So what is going on here? So cout object is being created. So we are creating an object at this particular time. So that's why this message will be popped up whenever we actually trying to create an object of line class. Now just a quick look to the other functions. So set length is setting the length by this variable, and get length is actually returning the length. So we are getting, or we are accessing the private members using some public functions, set length and get length. So inside the main, so we have declared this particular so this is the line object of class line. So as I said earlier that whenever we execute this particular line, so let's just remove everything. So let's just comment out everything. So we have only single line, line. So let's check what is happening if we execute this particular code. So as you can see, object is being created, that is shown here. That means this particular function is being executed whenever we are actually trying to create an object. So let's create another object. So line 2, suppose. So we have now created two objects, line for line class, line 1 and line 2. Let's check what is the output. So as you can see, two times that particular object is created, message as displayed. That means we have created two objects. So from this, we can confirm that this line constructor is being executed whenever we are trying to create a particular object of this class. So just remove this and we are going to use this set length function. So we have set the length to 6.0. So what is happening? So whenever we create this particular object, line object, so what is happening? So we have a line object and the length, suppose L is equal to 6.0 is set from this particular statement. So after executing this, we have got our object like this. Now what we are trying to do, we are trying to just display the length using the get length function. So length of line is equal to, or whatever, colon is equal to line dot get length, then just line. So what should it print? It should print for this particular line, it should print object is being created, and for this particular line or this particular cout statement, it should print the length of line is 6.0, as we have set the length as 6.0. So let's check it. So as you can see, object is being created and length of line is 6. Now what I was trying to say, that we can actually use this particular facility to actually initialize our object. So what we can do, suppose we want some default value. We actually cannot write or initialize any value or any data member like this. So this is actually not valid. So we cannot actually initialize any instance variable. So what we can do, so as we have now confirmed that whenever an object is being created, a constructor is being called. So within that constructor, we can actually initialize those values. So suppose we are initializing length is equal to 10.0. So what I am saying here, that by default, if we don't set any length, so if we don't set any length using this length function, set length function, by default, all the variables or all the objects will have the length of 10.0. So let's run this particular code and expect what is the output. Let's check it. But before that, I am just trying to predict the output. So if this line is executing, then this piece of code will be executing and it will set the length to 10.0 and object is being created will be printed. And for this particular line, we can see that line.getLength will print 10.0. Let's see. So as you can see, object is being created and length of line is equal to 10. So we have get our result. That means this is actually happening. That means by default, this particular line is being initialized with 10. So suppose we take another line variable, say line 2, and what we are going to do, we are going to set the line 2 as set length and just print line 2 here. So we are calling this line 2 dot get length. So for line 1 or the original line variable, we have not actually set the length. For line 2, we have actually set the length. So we can do another thing. We can just print the length of line 2 before setting the value. So length of line before, length of line 2 actually, and length of line 2 after. So before and after will tell us what will be the length of line before we set the line to as 6.0, and what will be the length afterwards. That means after setting the length 6.0. So let's check it. So as you can see, for this line and line 2, we have these two lines, object is created, object is created. Now, as we know that for every object, the initial value will be 10. So when we have printed length of line 2 before, it is 10. So as you can see, length of line 2 before, it is 10. And then we set the value or the length to. Then we have set the length to 6.0. So that's why afterwards the length of line 2 becomes 6.0. And we have also printed the length of line, that is 6, because we have not changed that particular value using setLength function. So this is how a constructor works. So constructor is automatically being called at the time of object creation, and we can actually use that particular opportunity to initialize our objects. So the example that we have seen, they are called the default constructor. That means a constructor that doesn't takes any value and sets some default value or nothing else. So a constructor that doesn't takes any value as an argument, that is called a default constructor. So there are three different type of constructor: default constructor and non-parameterized constructor that we have seen in our previous example. Then we have a parameterized constructor where we can pass some arguments to the constructor, and depending on that argument, we can actually initialize the values of our objects. And thirdly, we have some copy constructor. There are some interesting facts. This parameterized, whenever we define a parameterized constructor, that means a constructor that takes parameter, compiler will stop providing us the default constructor. So if default constructor is not provided, object will not created. So the creation of object is actually the job of constructor. So if default constructor is not created, then we cannot write this kind of statement, say line. What we have to write, we have to always use parameterized constructor to create an object. We cannot use this kind of statements if parameterized constructor use. So compiler will stop providing the default constructor. Compiler also provide another type of constructor is called copy constructor, and it is provided regardless of we have used a parameterized constructor or not, default constructor or not. It is by default provided by the compiler, but in certain situation compiler actually doesn't provide copy constructor. We are going to look into that in a bit. We are going to learn copy constructor as well as parameter constructor this time. So let's move on to this parameterized constructor. So this is the example of parameterized constructor. So what we have here, so we have a constructor definition with some arguments in it. So double length. So what this constructor is going to do is so set the value of this particular length with this len operation. So and all the other operations or all the other members of this particular class is similar to the previous one. So we have this length function, we have these two functions, and I have this particular comment. So I will come to that later. First, just assume or just look at this particular constructor. So it is same as functions. So functions without parameter, that is a default constructor like this, and function with parameter, that is this. So you can have as many parameters as you want, as many arguments as you want inside this parameter box or inside this braces. Just now define the constructors or all the members or all the functions of the class. So what we have here, we don't have any return type. That's why we just mentioned the class name with the scope subdivision operator with the function name. Function name in this particular case, it is a constructor. That's why function name is same as the class name. So line and the argument list. So double name. So what we have done here, we have just printed a message object is being created and length that has been taken as an input to this particular function is printed. So object is created, length is equal to something like say if 10 is given, so it will print 10 and length is equal to length. So we have set the length as equal to this particular variable. Initially, in our previous example, what we have done, we have set the length is equal to 10 by default. But here, we are not setting any default value. We are actually setting some value that has been given to this particular constructor. And now these two codes are same because we are setting the length and we are getting the length. So after learning this parameterized constructor, we can actually omit the use of this set length function. We can actually omit the use of set length function because now we can actually set the length or set the values of any object using this parameterized constructor. But there is no harm in setting the length using set length function or setter functions as well. So what we have here, so inside the main we have this kind of structure. So what is happening here? So if you have a default constructor, the object declaration will not change. So it will look like this. So object declaration will not change if you are using a default constructor. But whenever we have a parameterized constructor, the object declaration will change slightly. What will happen? So we have this line, then this object name. So line, and then you have to pass the arguments. And these arguments will have to be the same type and same number of arguments that we have given uh, in this particular constructor. So in this particular constructor, we require a double value. That's why in this particular statement, we have sent line 10.0. So 10.0 is the double value that is being sent to this particular constructor. So what will happen here? So for this particular line, so if we just forget everything, suppose if we have forgotten everything, so just if we forget everything, not even this one. So if we forget everything and just execute this line, so just try to predict the output, then I'm going to execute the code. So it should be like this: object is being created, length is equal to whatever value, so 10.0 and nothing. So just execute this. So as you can see, object is being created, length is equal to 10. That is the output. So that was we have expected. That means this time a parameterized constructor has been called. So now what I was saying, that whenever you write a parameterized constructor, you cannot use the default constructor. So if we have a statement like this, so this statement will give an error. So I'm just showing you the logs. So as you can see, yeah, as you can see, no match function to call line. So we don't have any function that or any constructor that can actually define or be called in this particular situation. Because if you write your own constructor, if you write your own constructor in your program or in your class, compiler will stop providing the constructor. So what we can do, how we can just eliminate this particular error, or how we can create some objects without any error. So what we can do, we can just write our own default constructor. So this is our own default constructor, where this default constructor actually doesn't do anything. That's why I have kept it empty. You can just set any length, any random length as well. So equal to, suppose, 1.0. So by default, all the lengths will be 1.0 as well. So you can set that. You can set some custom messages as well, that like default constructor is called, parameterized constructor is called, something like this. So but by default I have set is empty because we actually don't need it. By default, if you just write this, your all data members will be defined or will be actually initialized by the default values. Like for int, it will be initialized with 0. For boolean, it will be initialized with false. For float, it will be initialized with 0 0.0. For double, it will be initialized with 0 0.0, something like this. For character, it will be a null character maybe. For string or for pointers, it will be null pointer. So there is no need to specify anything. If you are actually concentrated about the parameterized constructor, just write down this particular statement so that you can write this particular type of statements. So just execute this. So as you can see, the program executed successfully. That means we don't have any error in this particular code now. So we don't have any error in this particular code now. That means the default constructor and normal constructor, parameterized constructor are working fine. Now just let's move into this codes. So what we have here. So for now, just skip this section, or we don't need this now. So we have set the default value using the parameterized constructor. Now we want to print the length. So it should print 10. And then if we set the value to 6 again, it should print 6. So just take a look at this particular code. So object is being created, length is equal to 10, length of line is equal to 10, and after setting the length is equal to 6.0, the length is now become 6. That's why it has printed length is equal to length of line is equal to 6. So this is how parameterized constructor are working. Now there is another thing I want to show you guys. So that is this particular statement. So here what we have, so we have line 3 is equal to line. So what is it? So this is actually copy. So what is going on here? So we have this line here, and the length is suppose 10.0 because we have this initial length for line. So whenever we are actually using this particular statement, line 3 is equal to line, what is happening? Another object called line 3 is being created, and the length is being set to 10.0. What is happening here? The values of this object, that means the instance values of this particular object is being copied to the newly created object. And here so if we execute this particular code, you can see that this particular code is running fine. Just remove this particular statement. That means we are just now removing this particular statement, because you can consider this like int a is equal to 5 can be splitted as int a is equal to 5. That's why I have removed that particular statement. So what will happen now? Just let's check it. So I have removed this particular statement because we know for this kind of statements, we need this particular constructor to create the object. But even though the program is running fine, that means something is going on that is in this particular statement. In this particular statements, we are not actually calling the default constructor. So what is happening here? Here, by default, the compiler is providing us the copy constructor. So this is not actually copy. This is using the copy constructor. So this constructor is using in this particular line. That's why when we have used or we have omitted the default constructor the program is not executing properly. So for your satisfaction, I am just turning on this particular statement because you are confirmed from our previous running that this particular statement actually requires the default constructor, and so just check it out. As you can see, you have got an error here. That means default constructor is required for this particular line, but default constructor is not required for this particular line because a copy constructor is being used in this particular statement. So as you can see, running fine. So that means a copy constructor is being used in this particular statement. And we are going to learn how to define our own copy constructor. So generally, if you use any default constructor or parameterized constructor in your program, you do not need to write the copy constructor because copy constructor is by default provided by the compiler. In three different situations, I will mention those three situations when we going to learn about copy constructor. So this is how a copy constructor is working. So let's just quickly take a look at what is happening here. So as I said, these two are two different objects. They are not the references or nothing. They are two different objects. For that, I have this particular example. So we have printed the length of line. Then we have printed the length of line 3 and printed the length of line 3. So we have these two lines were there previously, so I have added just two lines. So I'm just trying to print the length of line 3, and after setting the length of line 1, again I am trying to print the line 3. So just quickly look at the output. So as you can see, object is being created, length is 10 for this particular statement. For line 3 is equal to line 3 for this particular statement, neither the default constructor, neither the parameterized constructor has been called, because if the parameterized constructor has been called, then it should have printed object is being created, length is equal to whatever it is. But that is not the case. That means we can assume that, or we can assure that from those two constructors, none of them were executing. Now, for this line 3, we have length of, for this line 1, we have the length of line 1 is 10. For line 3, we have 10 again, and we have set the line 1 to 6.0. That's why the length of line 1 is 6. And for a length of line 3, we have 10 again, because line and line 3 are two distinct objects. That's why when we actually change the length of line, it doesn't reflect on line 3. But if you are going to create another object, say line 4 is equal to line, afterwards it will have the value of 6, because we have created after modifying the value of line. So this is the example of parameterized constructor and some more knowledge about default constructor as well as copy constructor. So now copy constructor. So what it does, it initializes one object from another object of same time. So we have seen that example, right? Why how copy constructor is being used to create a new object or initialize a new object from another object. Copy constructor object to pass. So we will come to that. So the compiler itself defines one. So if you don't have any copy constructor, it will be defined by the compiler. But when or in which situation we don't get the copy constructor from the compiler? When there is a pointer variable used in our program, or we have some dynamic memory allocation related to that particular code or particular class. At that particular situation, default copy constructor will not be provided by the compiler. So how can we write, or how can we actually create a copy constructor? For that, the formula is simple. No return type, constructor name will be the class name, and inside that we have to pass the object. So passing an object is very simple, class name and object name. Now this is tricky one. Why we are using the reference here? Why we are using the reference one? So as I said, if compiler doesn't provide us the copy constructor, we actually cannot use the copy. So we cannot send as a value, because what will happen if we have, or if we send the suppose this particular thing is not here, that means whenever we call this particular constructor, or whenever we try to, suppose line line is equal to line 3 is equal to line, so that means what is happening here, this particular object is being copied to in this particular variable. So line will be copied here in this object, but copy constructor is not there for that particular class. That means copy is not possible. That's why what we are using the reference. That means this line will be renamed by this. Suppose this there is line, so this object. So if we use this reference, it will be renamed by the object. That means both of them pointing to the same location, same object at this time, because we don't have the copy constructor for this type of classes where copy constructor is not provided by the compiler. And why constant? Why constant? Because we don't want to change the original object. So by any chance, if you change the original object, it will hamper this original object. That's why we don't want to change that original object. That's why we have set this particular object or this obj. So obj cannot actually change or modify the values here. So this is passed by reference. That means whatever changes we are making to this object will be reflected in line. But as we have made this constant, it actually limits the capability of this pass by reference, and we cannot actually change the permission of changing anything on this particular object is now revoked from this reference. So what we can do, we can just use this reference to create the new object or set the values for this new object. Now in three different situations, compiler actually provide us the copy constructor. So number one is equal operator. So when equal or assignment. So when equal, you are using statements like say line is equal to line 3 is equal to line. So in this particular assignment type of operation, compiler actually provides the copy constructor by default, or actually uses the copy constructor by default. Number two, when we send an object as an argument. Pass by value. That means the examples we were using in front class as like that, when the objects are sent as a pass by value. So that means if we don't have this particular statement, that this becomes a pass by value. In this particular situations, actually compiler provides us this copy constructor. And number three situations, when function returns an object. So when a particular function returns an object, that object needs to be copied to a variable in the calling function. At that situation also, the copy constructor is used. So in this particular three situations, copy constructor is used by the compiler. And if the class has anything related to pointer variable or anything related to dynamic memory allocation, compiler will stop providing the copy constructor. At that time, we must define our own constructor using this kind of syntax. So let's check out how we can actually write a copy constructor in practical scenarios. So again, the same methods or same class. So we have this line. Now what we have done, so we have used a pointer here because we know that in this kind of situation, compiler will not provide us any copy constructor. That's why we are trying to use a copy constructor here. So we have defined a parameterized constructor as well, like in our previous case, and here we have this copy constructor syntax. So what is it? So the name should be the same as the class name, then constant, class name, and object. So object is passed by the reference. That's why we have this ampersand sign here. So the definition of parameterized constructor looks like this. So parameterized constructor allocating the pointer. So we are trying to allocate the pointer to the length or to this particular variable. So what we are going to do? So we are going to create a new integer for that particular pointer. So we are actually allocating the memory at the runtime, and we are setting the value of that pointer to this particular length. So so it could be x or whatever value. So a integer value is being set to this pointer location. That means in this parameterized constructor, what is happening? So we have this pointer that is being created for integers, and we have some location where we put the length value, so whatever value this length captures, and then we set, suppose this is 2010, so we set this value 2010. So that is what happening here. That means if using this star ptr, we can actually access whatever value is inside this location. And now just this function is same, get length, so it will return the length. So as I said in our earlier example, that when we have this kind of parameterized constructor, we don't need the setter function. That's why we have omitted the setter function from this particular code. So as you can see in this particular class, now we don't have any setter function. We are using the constructor to set the values at the runtime. So in this copy constructor, what is happening here? So a particular message, that is we are inside the copy constructor allocating the pointer, and we are allocating the pointer to a new integer. That means another pointer, or this particular pointer is being created. And what we are going to do from that object, from that object, we are going to from that object we are going to take the value and assign that particular value in this particular pointer. So what is happening here? This pointer is taking the object pointer value. So here is some location, and this location is being copied to this particular section. That means this, suppose there is 5 and this is pointing to 5. So this 5 will be assigned here, and this will point here. So this is something happening in this particular constructor. So the value is being copied from the object to the pointer. And now let's move into the other functions. So this is the get length function, and we have this void display function. So this is a global function. This is not a class member. That's why we don't have any class or scope resolution operator. So void display, what is this? It finds the length of a line. So object dot get length, it actually finds the length, of an object, or actually prints the length of an object. So what we have done here, in the main function we have created a parameterized constructor. Using the parameterized constructor, we have created a variable. So line 10, right? And now we have sent the value, or we have sent this object as a pass by value. So as you can see, this line object is pass by valued here. That means this line should be copied into this object. That means uh, we must use a copy constructor, and if copy constructor is not provided by the compiler, so if copy constructor is not provided by the compiler, this particular statement should not execute. That means, because here a copy constructor should have been called, so if copy constructor is not provided by the compiler, or we have not written a copy constructor, here this particular operation will be invalid, because we have passed this line object as a copy to this formal parameter. So just let's execute this particular code. So as you can see, we have, for this particular line 10, we have a parameterized constructor. And then we have just displayed the line. So we have sent as an argument this line object, and that is being copied into this obj object. So for this particular operation, for this particular copy operation, this copy constructor is being called. So afterwards, this line length of 10 is being printed. So length of 10 is being printed. So we can take another example, or another way how can we invoke this copy constructor. So we can just turn on this particular line. So here we have copied one item from another item. So let's just separator here. Suppose indent. Suppose separator. So we have printed a separator here. So now if we just execute, okay. So now if we just execute it, it will be parameterized constructor allocating pointer, then copy constructor allocating pointer. So for this particular line, copy constructor is being called, and then this separator is being printed. And for this particular function, first of all, the copy constructor will be called so that this line object can be copied to this obj variable or obj object, and it is printing the content of the obj object or length of the obj object. And there are another way to call the copy constructor. So like this, suppose we have line 2 and this. So this will also call the copy constructor. So what will happen? Just copy this section. So we have another separator. So now 3 times copy constructor will call. As you can see, copy constructor, and copy constructor. So this way you can actually manually call the copy constructor, or you can actually use this equal operation for copy constructor. And the third way is sending some value as an pass by value, sending an object as a pass by value, that is also invoking the copy constructor. And when actually function returns an object, that is also invocation of copy constructor. So manually, by these two statements, we can actually use the copy constructor. Now, like for object creation, the constructor are automatically called. So whenever we are trying to delete or trying to revoke the access of a particular object, or the object goes out of scope, a destructor function is automatically cloned. That means if you want some code to be executed after the object is going out of scope, so you can write those segment of codes using the constructor. So this is also a special function like constructor and has the similar properties like constructor. It cannot return some value, it cannot take. And one of the important points is like constructor can take any parameters, but it cannot take any parameters. It will have nothing. The parameter list will be void, and it cannot return any value. That means this destructor cannot return any value. So what is the difference? The name should be the same as the class name. That means constructor name and destructor name will be same, but the constructor will be prefixed by this tilde character, a character like this, that is on top of your tab keyword. So shift and the key on your top, if you press that, you will find this tilde sign, and this tilde sign is preceded on the destructor, and they are being invoked whenever your object is goes out of the scope. That means whenever the object is not required anymore at that particular time, destructor is called. So destructor can be useful for releasing resources before coming out of the program, like closing the files, releasing memory. So if your class deals with a file, what you can do, you can actually close that particular file inside the destructor. So when your object is goes out of the scope, the file will be automatically closed. So we are going to check the code here. So this is a simple code. So the same thing. So this is the constructor that constructs an object, and this is the destructor. So a tilde sign and the same default constructor type of structure. So what we have done in the definitions, so in the constructor we have written object is created, and in the destructor we have written object is deleted. Now we have created a single object and then setting the length of that particular object and trying to print the length. So everything is fine. So length is created, so constructor will be called here, then this will be printed. And if we just execute this particular code, we can see a new line, object is deleted. That means when this main function is terminated, the this line object is goes out of scope, because the scope of this line object is from here to here. So when this line object is goes out of scope, the object is being destroyed, and it uses automatically executes this particular command. That's why object is being deleted is executing. By default also destructor is provided by the compiler. If you want to execute some code upon destroying that particular object or an object of particular class, you can define the destructor of your own. Now, dynamic memory allocation for objects. So we have seen this. We have in yesterday's in previous class, we have actually created an object using a pointer and tried to access some variables, some data members or some member functions using that particular pointer using the arrow operator. So today we can see that we can also create an array of objects. So what will be the syntax? So this is simple, just an pointer to the object is equal to new box. So using the new operator you can actually create an object. So what it will do, it will create 4 box objects consecutively. So this is suppose box 0. So this will be my box actually. So my box adding 0, this is 1, this is 2, and this is 3. So this is how you can create those objects, and whenever you want to delete those objects, you can use the delete operation. So this is how dynamic memory allocation works for objects as well, and properties, all the properties of dynamic memory allocation deallocation holds for objects as well, like they holds for any other primary type data. So let's just execute this code. Uh, So as you can see, so we have 4 boxes or 4 constructors. So the constructor will be called 4 times for each of this object. For each of the element of the array, the constructor is going to be called. And when we use this delete operation, so after this, let's put some statements. End of program. So let's just execute this. So what you can see here, and that constructor called, constructor called, constructor called, constructor called, that means 4 times the object has been created. That means 4 object has been created, and when you delete the object using delete operation, it has been deleted, and afterwards the end of the program is being executed. Now if we omit this particular statement and execute the program again, so we can see that constructor is called, constructor is called, constructor is called, constructor is called, and end of program. We have not seen the destructor object called. Why? Because whenever we create the memory using new operator, we must delete the object using delete operation, else they will not be automatically removed. In the previous example, we have seen that we have created some objects without new operation, and whenever it goes out of the main, that means whenever the program ends, object automatically being destroyed. But in this particular situation, the object is not being destroyed. That means memory is occupied, and the operating system has to take actions on that particular memory. So you must delete whatever pointers or whatever memory you have created using new operator. You must delete them using the delete operator. Now, this is interesting. So, uh, whenever we call, say, object dot, say, get, or any method, say set length, object dot set length 5. So we, what we used to write inside this function definition. So suppose we have this function definition inside the class. So what we used to do, we write void set length, suppose int a, and we set the length is equal to a. But when 2 objects, suppose this is belongs to class, suppose box. So box scope resolution operator set length. So suppose this is the function, and whenever we call this function with object 1 and object 2, have you wondered how, or suppose this is 15, so what will happen in memory? So here will be object 1 and here will be object 2, and when you use object 1 dot set length, it will set the value of length 5 here and it will set the length of 15 here. They are not actually setting the single value. So how the program, or how the computer is understanding which version of the function or which version of the instance variable needs to be updated, because we are not mentioning any object inside the arguments. In friend function we actually mention the argument, and using that particular argument we can set some values, but in this particular operation we are not mentioning. So what is happening, this object, so with that particular object, using which object we actually call this function, that object is implicitly available in the function definition. That means whichever object we are going to use for calling a particular function, that function is itself available inside this code, and only that particular member function or that particular member variable or data members are being used for manipulation. That means whenever we are calling object one dot set length, this length actually refers to this object one length, and whenever we call it object 2 dot set length, this length will now refer to object 2 dot length, that means this one, and we can actually get the object as well. So keyword this keyword is used to denote the object that has been invoked, or that is referring the, or that has invoked that particular function. So this is a pointer, it is not an object, this is a pointer. That means you can also write this dot length or this arrow length, because for pointers we use the arrow operator to access the member. So we can write this arrow length is equal to 8. So this statement and this statements are equivalent. So when we actually pass some objects through a member function, at that time, at that particular time, to resolve the confusions, what we can do, we can access these objects or the calling object that has invoked that particular function using this operator or this function, this pointer, and other members can be accessed using the object. So let's have a look at some example. So here is that box example again. So now we have a parameterized constructor here. Have we don't have any default constructor. That means we cannot use statements like, so I have not used any statements like box 2 or box 1 or box 3. We have three private member, length, breadth and height. We have a function to calculate the volume. We have another function int that will return the comparison between the volume. That means that will return either 0 or 1 depending on whichever value is greater than. That means if the current object, the volume of current objects is greater than the volume of the object that has been passed here, so it will return 1, and else it will return 0. So we have created two objects, box 1 and box 2. That means in memory we have this box 1 and box 2, and we have length is equal to, for box 1 that is 3.3, breadth is equal to 1.2, and height is equal to 1.5, and the volume can be calculated as length multiplied by breadth multiplied by age. Similarly, for box 2 we have length is equal to 8.5, breadth is equal to 6.0, and height is equal to 2.0. So the volume can be calculated from here as well, L multiplied by B multiplied by E. So what is happening here? So when we pass an argument, when we pass an object as an argument, like here we have passed an argument, a object as an argument. So what we have here, we have a confusion, which volume to be called, this volume or this volume. So what these volumes are different. So when we refer box dot volume, it is referring the volume, it is referring the volume of this box, because box 2 has sent, box 2 is sent here as a pass by value, whereas box 1 has called this compare method. So that's why box 1 is implicitly available here without using the this operator or with using the this operator. So volume, so if we use volume or say height inside this particular method or inside any member function, it will refer to the object box 1. And when we use box dot volume, it should refer to box 2. So what it will do is, this function will do, this function will compare the volumes and tell us which box is larger. So box 2 is equal to or larger than box 1. So that is what the case here. That means box 2 is not uh, less than box 1. So box 2 is actually bigger than box 1 or equal to, depending on whatever return value we get from here. So we have checked here if box 1 is greater than or not. So if it returns a non-zero value, that means box 1 is greater. If it returns a zero value, that means it is either box 2 either is big or box 2 either is equal to the box 1. So that's why it is written box 2 is equal to or larger than box 1. So this pointer can be used to actually denote the object of, or the object that has invoked that particular function. So similarly, if we have to return the current object or the object that has actually called a particular function, we can actually return the this pointer. So we have to return, we can return the this pointer in this method. So this is very useful in some scenario when we have multiple objects passed as an argument, or whenever we have to return the current object instance to the calling function. So now we move into another topic, interesting topic, static member of a class. So what is a static member of a class? So a static member is shared among all the objects. That means it has only one copy. So no matter how many objects we are going to create, it will have single copy, like the functions. So we have seen the structure of the function and instance variable. Instance variable have their multiple copies, and functions have only single copy. Similarly, static members will have single copy, and that copy will be shared among everyone, and it has to be initialized. So by default, static members are initialized with the default values. If we don't initialize it, uh, and we cannot initialize any value inside the functions, inside the class definition as well, as we have learned that earlier. So what we have to do, static members can be initialized outside the class using the scope resolution operator. So using the scope resolution operator, we can actually use this or initialize this as static member. So first of all, we look into the code, then we will deep dive into the static members and how they actually share among the data members. So again, we have the same set of code. Uh, So we have that private data member length, breadth, and height. We have a static member called object count. So how to define a static member? Just put static keyword before the definition of that member. So int object count, it was it would have been a public member, normally public data member. Whereas whenever I put a static keyword before that, it becomes a static data member. What will happen? So uh, I actually declare, whenever I actually declare some objects, so I say box 1 and box 2 in that case, and whenever all the data members are have their own value, so L, B, H, so it should have that particular variable name as object count. object count, suppose. So obj count L, B, and H. So this should happen. But in this particular case, that is not happening. That means in this particular scenario, we will not going to have an object copy or copy of this particular function. So this object or this particular static object or static member, this particular static member will not be stored with this box 1 and box 2. That means this box 1 and box 2 will not have their own copy for static members. Only for data members or instance variable they will have their own copy. Static member is not belong to any of the object. It belongs to the class. It is a class variable. So this is another kind of variable available in C++ that is called class variable. So all the static data members are actually the class variable. They belong to the class. We have the same constructor, and this time whenever we construct an object, we actually increasing the counter, or so we are actually increasing the value of the object by 1. So what we have to do, we have to initialize the object count first. So to initialize the object count, we have to come to this part like function definition. So we have initialized the object using the scope resolution operator of the class. So int, that is the data type, then class name, scope resolution operator, object name, static object name is equal to 0. So this is how we have initialized our static data member. And inside the main we have created two box, and now we want to print how many objects or how many objects we have created. So it will result 2, because whenever the object or whenever that particular box constructor has been called, we have increased the object count by 1. So from this we can know that, so if box 1 and box 2 has their own copy of suppose or has their own copy of this object count, we could not have get the value as 2. And look at this particular call. So object count is a private public member, that's why we can access it from outside the class. And for this object count we are not going to use any object, we are actually using the class name with the scope resolution operator. So that is the thing, that object count, this variable actually belongs to the class. We cannot use that for any other member. We cannot call a function that is not a static using the class, because they belong to the object. So we need to use them or we need to call them using the object. But static members are not bound to the objects, they are independent, they are for the class. So that's why we have to call or we have to use the static member using the class name. So if we just run this particular code, it will constructor called, and two object has been created, because two times constructor has been called, two object has been created in this particular scenario. So this is how static members basically are. So let's deep dive into static members. So this is what happening. So we have for object 1 and object 2, suppose two objects of some class will have the copy of instance variables. But like member functions, data member and static member will be shared among them. Only single copy of the static member, only single copy of the data member is available, as well as for the member functions as well. So we have seen this member function before, that member function is shared among all the objects, but now we can see that static members and static member functions, both of them can be shared using object 1 and object 2, and they will have only single copy. They are not being copied to instance variable like instance variable. So that's why static data members are called class variable, and static member functions called class functions. So static member functions. So the idea is same, but what is different now? A static function can be called without using an operator. So what we have to do, we have to use the class name with the scope resolution operator. Using this class name and a scope resolution operator, we can actually call a static data member. Interesting thing is that static member function can only access static data member. No other normal data members are not accessible by the static data members. Static functions, and it can also use some of the outside functions. That means the functions that are not belonging to the class. or the global functions, they can be called inside the static member, but from the class only the static data members and static member functions can be accessed by this static member. So static members have a class scope. So uh, you do not need to have an object for calling this static member function. So similarly, if we don't call a member function using an object, we don't have access to this pointer. So this pointer is not available if you are using a static member function. So what we can do, or how we can use a static member function? So we can use static member functions to know how many objects has been created, or whether some object has been created or not. So let's look at the example. We have just modified the previous code a bit. So now what we have here, we have this static int object count as a private member. So anything, any specifier, if any specifier is not specified in the class, it is treated as a private. So this is now a private member, and these are the private members from before. And now what we have done here, we have a new method, static int get count. It will return the object count. So as it is a private member, to return that or to get that particular value, we have used a static method int get count, and that will return this object count. So what we have here, so first of all, at the initial state, first of all, at the initial state, we are trying to count how many object has been created. At initial state, no object will be created, and also the static variable is initialized with 0. So there are two members, static members. One is this object count, and another one is this static get count. So at initially, as no object has been created, that means the count will be 0. So the count is being increased while or whenever we actually call this particular parameterized constructor. So after creating two objects, the count should be 2. So let's take this example. So as you can see, initial count is 0. After creating two objects, the count becomes 2. So this way we can actually keep track of how many objects has been created, and this particular function, or this particular function and this particular variable, are not bound with the objects. That means they will have no effect on the number of objects we are creating. They will not get a single copy. Sorry, they will not get their individual copy for this object count variable. They will get a single copy that will be shared among everyone. So that is it for today's lecture. On the next day, we are going to explore a particular term called polymorphism, and we are going to look into some of the examples or how polymorphism works in C++. Thank you, everyone.